Hi, everyone. Thanks so much for coming to this session today. So my name is Merrick, and I'm a soon-to-be third-year grad student at Indiana University, and I work with Dr. Emily Fife. So today I'm going to be presenting the results of a project titled The Effects of Person versus Computer Feedback on Children's Performance in Mathematics. So feedback is a really important tool for cognitive change. Most of the time, feedback about student performance has positive effects. However, these effects depend on a variety of variables, such as feedback type, task type, and student knowledge level. These potentially negative effects of feedback has made us reevaluate which features of feedback are effective in triggering positive cognitive change. One leading theory, referred to as feedback intervention theory, attempts to explain when feedback has helpful versus hindering effects. So according to this theory, feedback has the potential to direct the learner's attention to task-level processes, like examining the structure of a problem, or to meta-task processes, which include attention to the self. So feedback is more likely to hinder performance when it directs attention to the self because less cognitive energy is being used to solve the task at hand. So attending to the self in addition to the task can overwhelm one's cognitive resources, produce affective reactions that will reduce motivation and willingness to explore problem spaces, and distract from task-relevant processes. So keeping this important theory in mind, we imagine that person-based feedback might heighten this attention to the self compared to computer-based feedback, and therefore may influence children's performance on foundational math tasks. So some research is consistent with feedback intervention theory, finding that computer-based feedback has benefits relative to person-based feedback, as this lack of social information makes it easier for students to focus on the task. However, this research is very limited, so we want to expand this. And the majority of benefits from computer-based feedback have been found with participants with low prior knowledge or that are more prone to failure. There have even been some contradictory results in the literature suggesting that outside of STEM contexts, person-based feedback might actually have better learning benefits when compared to computer-based feedback. So these contradictory results and limited research in this area really questions the robustness of the effective feedback from these differing sources. How does source of feedback affect different kinds of learners, and do these differences generalize into multiple contexts that are outside of academic domains? So overall, using feedback intervention theory and past literature to guide us, we hypothesize that within the domain of early mathematics, computer-based feedback will increase students' performance, which we are measuring as accuracy and strategy variability, compared to person-based feedback, as computer-based feedback brings less attention to the self than person-based feedback. Well, feedback can also vary in complexity as well, in the complexity of the content, as well as who it's coming from. Therefore, we've also decided to alter the type of feedback in addition to the source. So we chose to compare verification feedback, which was shown in the red and green boxes here, with correct answer only feedback, shown in the blue box here. So correct answer only feedback gives just the answer and no other information, while verification feedback gives the correct answer as well as an explicit correct or incorrect signals, or a right-wrong judgment. So past research on feedback has compared verification feedback with more elaborated feedback, and few studies have explored the effects of answer-only feedback as the baseline minimum. And we believe this contrast is really important to explore, as verification cues and feedback might also heighten this attention to the self. Oh. Oops, yes. Once again, using the theory and past literature to guide us, we hypothesize that in the domain of early mathematics, answer-only feedback will increase child's performance compared to verification feedback, as verification feedback brings heightened attention to the self. So we're investigating these hypotheses about feedback source and feedback type in the context of children solving mathematical equivalence problems. So these problems are often found that have operations on both sides of the equal sign, and they're foundational for arithmetic and algebra understanding. However, children in the US exhibit a lot of misconceptions about equivalence, and they use entrenched strategies from arithmetic. Therefore, we're not only interested in investigating performance in regards to accuracy and about whether they solve them right or wrong, but we're also interested in the strategies that they choose and whether they're using a variety of different strategies or these strategies remained entrenched. So you may be wondering, what are the kinds of incorrect strategies that children use when solving these problems? So some examples are carry, where the child simply takes one number from the left side of the equation and moves it to the right. Another example would be repeat, where a child takes one number and repeats that in the equation. But we're especially interested in two incorrect strategies that stem from arithmetic practice. So these strategies are referred to as add all, where the child will just add up all of the numbers that they see regardless of where the equal sign is, and add to equal, where the child adds all the numbers that they see before the equal sign and ignores the rest. So we're interested to examine how differences in feedback not just affect performance, but how their use of strategies and reliance on arithmetic strategies changes depending on the feedback we give them. So to accomplish this, we designed a Zoom study with 6 to 8-year-olds, again on this topic of math equivalence, with a baseline measure of prior knowledge, which is a learning activity, and then prior knowledge, and then we had a learning activity with 4 different conditions where we manipulated both feedback source as well as feedback type. So in this baseline measure, we split our sample into high and low knowers to better understand the effects of feedback for different learner types. During the baseline of prior knowledge, we asked children to identify the equal sign and give their definition of what this means. Then we had students practice equivalence items without giving them any feedback. So 2 of these items were symbolic and 1 of them was numeric. But the primary manipulation where we manipulated the feedback happened during the learning activity. So this learning activity was framed as a computer game, and children were asked to type their answers into the chat function of the Zoom call. So there are 4 questions in this game, and after every 4 questions, the child completed a level and was asked if they wanted to keep playing the game or they wanted to stop playing the game. So there are a total of 5 levels that the child could have completed, so that's 20 questions in this math game. And we quantified children's performance in 2 ways. Again, strategy, accuracy, so accuracy being the proportion of questions that the children answered correctly, depending on how many they chose to continue answering, and strategy variability, which is the number of different strategies that children use when answering these questions. And again, we also looked at the use of specifically arithmetic strategies, which I alluded to previously. All right, so here's an example of the 4 between conditions that the children could have seen. So over Zoom, again, we manipulated feedback source, so whether the experimenter stayed on the Zoom call or they just played the game with the computer, and we had a manipulation check to make sure that the child thought that there was no experimenter watching them. So it was really with just the computer, or they were being observed by the experimenter, and the experimenter was giving them a verbal feedback at the same time. We also manipulated feedback type, which the inclusion of the verification of the right-wrong judgment, where children also heard a sound effect and saw a symbol relating to their performance. So example, if a child got the answer right, they saw the green check, and an ascending scale, if they got it wrong, they saw a red X, and a descending scale, and if there was no verification cue, they just heard a neutral tone, and there was no symbol relating to their performance. So let's on to the results. Children did pretty well overall in our baseline. They solved a little over 2 questions correctly out of 4. And we think that they had a higher performance here because our baseline was not a lot of the tasks were non-symbolic, and it followed a narrative structure which scaffolded their success. So that could be a limitation here. According to our model, the conditions were very similar at baseline. So for subsequent models, we chose to include prior knowledge, as past research has suggested that feedback depends a lot based on the student's prior knowledge. So out of 4 questions, if they scored 0, 1, or 2, they were categorized as a low knower, and if they scored 3 or 4, they were categorized as a high knower, and obviously there's a big discrepancy here, 30 low knowers and 72 high knowers, and that's obviously another limitation, but something to keep track of. All right, so for our first performance measure, it was accuracy, when I'll remind you that's the proportion of questions that children answered correctly out of the number of questions that they chose to answer. So our model showed a main effect of prior knowledge, as to be expected, and it also showed a main effect of feedback source. So computer feedback resulted in higher accuracy than person-based feedback. And this effect seems to be slightly stronger for low prior knowledge students, but this interaction between prior knowledge and feedback source was not significant. Our performance measure number 2 is strategy variability, or the number of different strategies that children used when answering the questions. So we would expect that low knowers would use more strategies than higher knowers, as high knowers are more likely to already know the correct strategy here. But we see that kids are quite variable, and they average using 3 different strategies, incorrect strategies, over the course of the problem. And the model revealed one significant effect, an interaction between feedback type and prior knowledge. As you can see, those with higher prior knowledge were not influenced by feedback source or type, but for low knowledge learners, verification seemed to hamper their exploration and reduce the number of different strategies used. Finally, we looked at the use of arithmetic strategies. So this only focuses on 85 children who answered at least one of the problems incorrectly. So across these incorrect items, children use arithmetic strategies about 54% of the time, and our model revealed a significant feedback type by prior knowledge interaction. So for low knowledge children, receiving the correct answer with verification feedback resulted in more frequent use of arithmetic strategies relative to receiving the correct only answer feedback. However, for high knowledge children, the addition of this verification cue didn't matter. They used a similar number of arithmetic strategies with verification or without. So these results suggest that verification feedback tended to reduce children's exploratory behavior, lowering strategy variability, and promoting some of these entrenched strategies, at least for our low knowledge group of children. All right, so overall, we are really interested in which features of feedback were effective in triggering positive cognitive change, or how can we improve performance of math tasks with children by utilizing this important pedagogical tool of feedback. So we investigated this within 2 key variables of feedback, feedback source and feedback type, and found that they each work differently to affect performance on children that were completing a mathematical equivalence test. Overall, our results aligned with feedback intervention theory, where features of feedback which heightened attention to the self decreased performance and exploration. So person-based feedback harmed accuracy for both high and low knowers, but especially our low knowers. And verification feedback, or this inclusion of a right-wrong judgment, harmed low knowledge children, lowering their strategy variability, and their overall use of arithmetic strategies increased, again, and their willingness to explore possible other solutions decreased. So thank you very much. I want to thank my lab and my advisor, Emily Fife, all of my research assistants, where this work wouldn't have been possible with them, all the families who participated in our research, and my funding sources. And let me know if you have any questions. Thank you very much.